Okay, so the very first question on your homework was x cubed plus 3x squared. So we're going to go to y equals. We're going to clear out anything we have in our y1. We're going to type in x cubed plus 3x squared. And personally, just looking at this as I'm typing it in, and somebody that kind of knows how we factored and looked at stuff in the past, I see x cubed and x squared. So in my head, I'm already thinking, okay, I have a GCF of x squared, which means that I'm going to have a root or a 0 at x equals 0 because it's going to factor out. So I'm going to hit zoom. I'm going to go to option 6, just so my graph is centered perfectly from -10 to 10 on both. So I can see that my graph goes up and down. It starts low and ends high. So that tells me that this is an odd function with a positive leading coefficient, which again, I can see here, odd positive leading coefficient. To fill in the table, you could just go second table. And again, my table on my calculator is, okay, my table on my calculator is a little empty because I have mine in ask. Your table might be set to auto. So if you go to your table, it'll automatically fill in numbers and you can fill in your table. To find the zeros, we're going to go to second trace. We're going to go to option 2. So the zeros are where it crosses the x-axis. So in this case, my 0 is going to be right here. So where it says left, I need to go below. Hit enter. Then I need to go above the 0 and hit enter. So those dashed lines are around the 0. Your guess doesn't matter. And I see that I have a 0, aka a root at -3. And then I can find my min or max. So if I go to max, that means I'm going to have the highest point. So I'm going to go to the left of the highest point, hit enter, go to the right, hit enter. Again, the dashed lines on the side should point inward at that max. And I see that it has a max at -2, 4. So the maximum is the y value. The x value is the point at which it occurs. So it occurs at the point -2, 4, but the max is 4. And then we have a min. My min is also going to be at a 0, so I'm going to hit enter to the left, enter to the right, enter one more time. Sorry, I hit max. Go to min, go to the left, enter, to the right, enter, hit enter that one final time. And when you get these -e to the 7s and -e to the 12s, that's your calculator finding 0, 0. So our calculators have a hard time with 0, 0 sometimes. But anytime you have like -e to the 7, -e to the 12, it represents 0, 0. And again, if you go to your table, you can see that we have the point 0, 0. So I have a 0 at 0, 0, as well as a min at 0, 0. Okay? So that is how we use our graphing calculators to find mins, max, and zeros. All of your homework was using the graphing calculator to do that. At the beginning of the warm-up, one of the things I mentioned to you was that when I saw that problem, my very first thought was to factor it. So in the next lesson, that's exactly what we're going to be working towards. We're going to be taking ideas and factoring them. So what happens if we have a function and we can factor it. Well, we can use factoring techniques to find our roots. So go ahead and take your notes, turn them to that next page. We are starting lesson 6.5, which is on solving polynomial equations using algebra. So on Friday, we solved polynomial equations using the graphing calculator. Today, we're going to solve polynomial equations using algebra. Okay, guys, make sure your masks are on over your nose and to your chin. All right, so with that, we have some vocab. A prime polynomial. A prime polynomial is a polynomial that cannot be factored. A prime polynomial is a polynomial that cannot be factored. And then we have quadratic form. Quadratic form is the form of an expression that can be written as a quadratic, even though it does not begin as a quadratic. So a prime polynomial is a polynomial that cannot be factored. And then one of our techniques is to rewrite using quadratic form. So let's go back and kind of reiterate some more vocabulary. If you recall, in Chapter 5, we had some factoring techniques. One of our most basic factoring techniques was known as the GCF. So when you had something called the GCF, what you did was take your number of terms, which could be any, and you took out a GCF. So here's an example where we are taking out a GCF. We have 4a cubed b squared minus 8ab. So we can take a 4 out of both, an a out of both, and a b out of both. So my GCF is 4ab. And that leaves behind a squared b minus 2. We learned a technique called the difference of squares. In the difference of squares technique, you had two terms. You had an a squared minus b squared. And that always factored as a plus b, a minus b. A new formula, one we haven't talked about before, is called a sum of cubes. A new formula, one we haven't talked about, is called a sum of cubes. So you have a cubed plus b cubed. That always factors as a plus b quantity a squared minus ab plus b squared. So the a represents the cube root of a cubed, the b represents the cube root of b cubed. One thing to notice is the term or the sign in front of b squared is positive. I know, I'm trying to make it bigger. So a difference of 2 cubes is a cubed minus b cubed, where you have a minus b, a squared plus ab plus b squared. So if you have a plus, it's plus, a minus is minus. The second term is the opposite of what you start with, and the last term is always positive. So that's the cases we're looking for if we have 2 terms. If we have 3 terms, then we're looking for our old cases, which are a perfect square trinomial. So a perfect square trinomial is when you have 3 terms and it has a perfect square at the beginning, a perfect square at the end, and the middle term is represented by 2 times a times b. And that always factors as a plus b quantity squared. We have our factor by grouping-ish technique, where you multiply the first times the last, and you find this factors that sum to the middle. If you have 4 or more terms, then you're going to use the technique called factor by grouping. So you group the first 2, you group the last 2, you find the factors between them. So you have ax plus bx plus ay plus by. So you group the first 2, you group the last 2, and you find their GCF. So as we work through our problems today, those are the techniques we're going to be looking for to help us factor. Okay, so in example 1, our goal is to factor the polynomial completely. And then if it cannot be factored, then you're going to write it out as being prime. So let's start with examples A and B. In example A, we have 16ax to the 4th plus 54xy cubed. So what I want to notice, or have you notice immediately, is that both terms have an x, as well as 16 and 54 both being even. And then you want to know what's the largest number that breaks into them. So 16 divides by 2, 4, and 8. So then what you would do is take your 54, divide it by 2, divide it by 4, and divide it by 8 to see if it divides by any of those, which it does not. And it does not divide by 16. So the GCF of those two terms is 2. And they each contain an x, so you're going to take out an x. So you can take out a 2x, and that leaves behind 8x cubed plus 54 divided by 2 is 27. Y cubed. But now, if you look at our techniques, we have 8, which is a perfect cube. X cubed is a perfect cube. 27 is a perfect cube. And y cubed is a perfect cube. So the first term, this becomes 2x, that's the cube root. In that second term, it's 3y. I have a plus sign between them. So according to my new techniques, this is a sum of 2 cubes. So you have a cubed plus b cubed. So we're going to factor it as a plus b. So my a plus b is right here. That's my 2x plus 3y. And then it's a squared. So 2x squared becomes 4x squared. If this is a positive, then in the sum of cubes formula, the next term is negative. The middle term is a times b. So you're going to multiply 2 times 3 to get 6xy. The last term in a sum or difference of cubes is always positive. And it's your b term squared. So 3 squared is 9. Y squared becomes y squared. So this part here factors as 2x plus 3y, 4x squared minus 6xy plus 9y squared. And you have to tag along or rewrite and bring down your 2x. So this is considered factored form. And again, what we're going to get to tomorrow is using factored form to find the zeros. So not today, but tomorrow we'll use factored form to find our zeros. Okay, number or letter B, 9 is a square, not a perfect cube. Y cubed, 5 is prime, x cubed. So even though I have a y cubed and an x cubed, 9 and 5 are not perfect cubes. Therefore, this is not a sum of cubes. I don't have a GCF because I don't have any common variables or common factors. So example B is actually an example of prime. Example B is actually an example of prime. Okay, example number 2. This is a factor by grouping technique. So I have more than 4 terms. I have 6 terms. So we have to kind of figure out logically where it's most sensible to group them. So in this case, what I want you to notice is that each of these terms here contain an x, and each of these terms here contain a y. So when I set up my factor by grouping, I'm going to group the first 3 terms that all contain an x, and I'm going to group my last 3 terms that all contain a y, so that I can use those as my common GCF. So 8, 4 and 4 all divide by 4. And like I said, each term contains an x. So we're going to take out a 4x. And that leaves behind 2a plus b plus c. And in the yellow, each term contains a 3 as well as a y. So once again, leaving behind 2a plus b plus c. When we set up factor by grouping, what's left behind in each of your factored parts needs to match. So that 2a plus b plus c needed to match in both, which it does. So my final factor by grouping answer becomes 4x plus 3y, 2a plus b plus c. So that is your final answer. You cannot stop here. You need to get to this level here. Okay. Here's another example. We have 1, 2, 3, 4, 5, 6 terms. So once again, we're either looking to group them in sets of 2 or sets of 3. It's usually easiest to divide by the number of terms by 2 and factor by grouping that way. So once again, what I'll notice is this term contains an F, an F. This one has a G. Here we have an H. So again, we're looking for common terms. We have G. This one has H, and this has H. But what we'll notice is that this term has Y, this term has Z, Y, Z, Y, Z. So what we notice is that each of those terms have Y's and Z's. So I'm going to rearrange them so that all of the Y's are at the beginning and all of the Z's are at the end. So I'm going to rearrange my terms so all of the Y terms come first and all of the Z terms come at the end. So a technique in factor by grouping is to look for common terms and switch them around. So that's why I was identifying the F's, the H's, the Z's, the G's, and looking at their commonality. Once you have all the Y terms at the beginning and all the Z terms at the end, we're going to take out our GCF. So here we have 20, 10, and 15. Each of those divide by 5, and each term contains a Y. So I'm going to take out a 5Y. Here I have an 8, a 16, and a 12, so they all divide by 4 and Z. So I take out a 5y, that leaves 4f minus 2h plus 3g. To get positive 4f, I'm going to take out a negative 4. So this 4f is positive because remember what's in here has to match here. We also know addition is commutative. So it doesn't matter that these terms were in a different order than these terms. Once we know addition is commutative, I can rearrange the order and take out my final GCF of 5y minus 4z. And I have my 4f minus 2h plus 3g. Okay, so like I said, a lot of these are going to be formula based. So what happens if I have an x to the 6th and a y to the 6th? Well, x to the 6th is kind of like a cube, as well as y to the 6th being like a cube. But they also both factor as perfect squares. Because this could be like x cubed minus y cubed times x cubed plus y cubed. So I'm going to start using my difference of squares technique. Because remember, any even-powered exponent is a perfect square. Any even-powered exponent is a perfect square. Now, each of these represent a difference of cubes and a sum of cubes. So I'm going to apply my formula. So my formula for a difference of cubes says it's the cube root of the first minus the cube root of the second times the first term squared plus the two middle terms multiplied plus the last term squared. So that gets me my difference of cubes. My sum of cubes is the cube root of x cubed, which is x, y cubed, which is y. It's a sum, so it's a positive. And then it's the first term squared, so that's x squared. And then you have a minus because it's the opposite sign. These two terms multiplied together. And then finally plus the last term squared. And then I just like to rearrange my terms. So I'm going to take the first x minus y binomial and the second x plus y binomial, which you should recognize represents a difference of squares, which is how we started this problem. So x minus y times x plus y represents a difference of squares. So I'm going to write those two terms at the beginning and my two non-factorable parts to them at the end. So when you use your sum or difference of cubes formulas, this part of the quadratic is never going to be factorable. If I use a sum or difference of squares, this part is never factorable. So if you use a sum or difference of squares, this part of the quadratic is never factorable. Okay, so the next part of this problem, example B, once again I have 6 terms, so I'm going to set up factor by grouping. Once you have more than 3 terms, you set up factor by grouping. So go ahead, take a minute, take out your GCF for each of those. So in the first grouping, my GCF is a cubed. In my second grouping, it's negative b cubed. So that leaves me with a cubed minus b cubed times x squared minus 6x plus 9. So now I'm going to factor each term separately. I'm going to use my difference of cubes on the first term, and I'm going to just factor this on my second one. X squared is a perfect square. 9 is a perfect square. X times 3 times 2 is 6. So this is a perfect square trinomial. This is a difference of cubes. So we're going to apply both of our formulas. So again, difference of cubes, perfect square trinomial. Your homework is those next pages in your packet. So if you are looking at your packets, which I have back here too. Okay, so we just did our examples. I guess you have 2 more examples. Sorry, let's do those last 2 examples. You know what? We'll do these tomorrow because I want you to just focus on applying your formulas. We'll do the quadratic ones tomorrow. So for your homework, you're doing 20. I don't want you to get to the quadratic ones. You're doing 20 to 29 only. So you're doing 20 to 29. Okay? Tomorrow we'll pick up with examples 5 and 6, as well as talk about solving. So for tonight, you're just doing 20 to 29. So the front and then that last one on the back.